So we are figuring out moment of inertia of uniform solid cylinder, but we are rotating along this length. So not along the axis of the cylinder, but perpendicular to that through the geometrical center, right? That's your geometrical center. Through that we have an axis that's perpendicular to your axis of cylinder. So we can name this as AB or something. Then what else we have? Then we have the cylinder to be of total length L. And so since this is the geometrical center and all of this, the geometrical aspect, it is divided into L by 2 and L by 2. So we are considering a uniform solid cylinder, thus making the density uniform with mass M and height L and radius R, rotating about its central axis. Wait, just a second. We can define its central axis. Rotating about its central axis, which passes through the geometrical center and is perpendicular to its length as illustrated above. Okay. Now, what is that we have to use? We have to use I is equal to R square dm. That's our starting point. Now, for R square dm and all of that, so what should we do? So we have to start by dividing. For above integration to take place, it would be, what would be convenient? It would be convenient to divide the cylinder into circular disc that is perpendicular to the axis of the cylinder. And of width and of dx thickness. Okay, I'll explain what is this. So you can see this disc, it's supposed to be just a cylinder, but in my diagram over here, I have a small disc, and that's the disc I'm talking about. This has a thickness of dx, and this is x units away. Okay, so this is x units away and this is of thickness dx. What else should I tell? And the radius obviously is r because, well, it's part of the cylinder and it is cut along the face. It's a cross section along the face. Now, let's consider as a next step, let's consider one such disc at a distance of x from axis of rotation. So this is axis of rotation. It's at a distance of x. Okay. So before we jump into all of this, talking about this, if I look at it carefully, it's a disc. Okay, I won't be able to animate. It's a disc which is rotating, or you can think of it's a circle, and you have a length and it's rotating in this manner. If you imagine this, say you have a circle, you take a stick along the length and you rotate it. Okay, so you basically are running around along the diameter. Now, if instead of that, if I shift the axis of rotation to this, and this being your line connecting the disc, imagine this rotating. Okay, imagine that rotating, and that's what we have over here. So can you see that both are interlinked? Okay, so we have shifted the diameter from here to this point. So this is a small note. I mean, actually, it's not a good diagram per se. So what I'm trying to tell is we are using parallel axis theorem. The reason being, we are considering the disk rotating along its diameter. So let me write it actually. Moment of inertia of a disk along its diameter. So let me write a small picture. So we have a disk and along here we have it rotating. Okay. So formula for this would be 1/4 of moment of inertia or I of a disk along a diameter is 1/4 mass times, I don't have enough space over there, 1/4 times mass times radius square. That's your formula. But here, what is the mass? Mass of a disk will be mass of the entire structure, that is M. I'm dividing along the length L and multiplying dx. That will give us the mass. And we have the radius of the disk is R. And so we have I of disk along the diameter will be equal to 1/4 M by L times of R times of dx. Okay, sorry, square. So this is the disk rotating, or a disk rotating along the diameter. But what if I shift the diameter now? What if shift the axis of rotation parallel to this? You will get this diagram actually. Think about it. This is the diameter. I'll try doing it. Yeah, actually I'll do it. Right guys, so this is the diameter. I'm shifting the diameter forward, and so I can use parallel axis theorem. You guys agree? So for many that's confusing, so I'm making it very clear. Now, so making use of this fact, we have moment of, wrong place. So we have moment of inertia of the disk with AB as axis of rotation. Okay, so this is our AB with that as axis of our rotation by using parallel axis theorem. What we have is I of disk along the diameter but shifted to AB will be equal to your M by 4L R square dx plus, again, mass times the d square, right? Mass is ml dx, and here d square is r, not r, x square. I hope you guys remember the parallel axis theorem. I am not going to go to that. Please turn your notes. Understand. Recall. Not understand, recall. So this is your mass and this is your d square. So I'll write it over here. That's your mass, this entire expression, and that's your d square. Okay. So yeah, we're almost there. So this is for a single disk, but we have many such disks. So now we have moment of inertia along the entire length. Along the entire length would be integration from I don't know if you guys know this, but okay, let me not. It's already long enough. I don't want to confuse you guys more. So we have to integrate from one end to the other end. So minus L by 2 to L by 2, right? And we have to add up each of this disk. So that is, I just have to copy this actually. 4L R square dx plus, as you can see, even I don't remember everything. It's not practical. So math helps, make use of it, and you will get the answer. So there is a property over here which I'm not using because, well, it's already confusing. I'm not going to write the limits because again, it is a lot of too many variables and stuff on the screen. R square, all of this is there, integrating dx. And the second term we have m by L, integration of x square dx, value, and this will lead to L. So LL will get cancelled. So m by 4 R square plus this is m by 3L, x cube integration is x to the power of 3 by x square integration is x cube by 3. And when I apply the limit, I'll get 2 times of L cube by 2 cube, that's 8. So 1s are 4s are. And we have ln square. See, I don't have to remember anything. All I have to do is just follow the math. And you will end up with the answer 12 L square. Done. Okay, so that's that. So this is the confusing part for many. So just be a bit mindful. It's not that hard.